We shall solve a few problems now that give rise to quadratic equations. See, problems leading to quadratic equations. See this problem. Find the quadratic equation, the sum of whose roots is 1 and the sum of the squares of the roots is 13. See here. Let alpha and beta be the roots of the quadratic required. Given alpha plus beta is equal to 1 and alpha square plus beta square is equal to 13. Sum of the roots 1 and sum of their squares 13. We have to solve these equations. There are many ways to solve these equations. You can solve by any method. See one of them now. Beta is equal to 1 minus alpha substituted here. Alpha square plus 1 minus 2 alpha plus alpha square minus 13 is equal to 0, or alpha square plus 1 minus alpha square whole square 1 minus 2 alpha plus alpha square minus 13 is equal to 0, giving 2 alpha square minus 2 alpha minus 13 plus 1 minus 12, or alpha square minus alpha minus 6 is equal to 0. Alpha square minus alpha minus 6 is equal to 0. Let us factorize. Simple thing is to factorize it. Please see here. So alpha into alpha plus 2, 3 into alpha plus 2 is equal to 0. Therefore, alpha plus 2 common, alpha minus 3 is equal to 0. You have solved several equations like this. Alpha is equal to minus 2 and alpha is equal to 3. So, beta will be 1 minus minus 2, that is 3, and 1 minus 3, that is minus 2. Understand quickly, this is giving you alpha is equal to minus 2, alpha is equal to 3, 2 roots, 2 values for alpha. If alpha is equal to minus 2, beta becomes 3. If alpha is equal to 3, beta becomes minus 2. So your equation x square minus sum of the roots minus 2 plus 3 plus product of the roots is equal to 0. You can take alpha is equal to minus 2, then beta is equal to 3, or you can take alpha is equal to 3, then beta is equal to minus 2. X square minus sum of the roots into x plus product of the roots is equal to 0. This will give you x square minus x minus 6 is equal to 0. A similar question is here. I am not solving. Identical question is here, not similar. Solving one more question, please see. The sum of the squares of two consecutive positive odd integers, consecutive, one coming after another, odd integers, positive odd integers. Look here, odd integers or even integers. Continuous, if you see, for example, see here 1, 3, 5, 7, or even numbers 4, 6, 8. You can see they differ by 2, whether it is odd or even numbers. Differ by 2. If one is 1, other one is 1 plus 2, or 3 plus 2, or 5 plus 2, like that. So I will take x and x plus 2. The reason for my so supposing arises out of the fact that odd numbers, continuous odd numbers, or shall we say consecutive odd numbers, form arithmetic progression with a common difference of 2, so also even. Now the question is, sum of the squares of 2 consecutive positive odd integers, see here, x square plus x plus 2 whole square is equal to 290. Proceed. X square plus 4x plus 4 minus 290 is equal to 0. Proceed. 2x square plus 4x minus 286 is equal to 0, or dividing by 2, x square plus 2x minus 143 is equal to 0. Why to use quadratic formula? We shall factorize. Simple trinomial factorization. X plus 13 common, x minus 11 is equal to 0, giving x is equal to minus 13 and x is equal to 11. Two values of x. My question says numbers are positive and odd. Of course both are odd, but question insists consecutive positive odd integers, so I must reject this value and accept that value. X is equal to minus 3, don't write reject or don't say reject, being not admissible. X is equal to 11. Therefore, the consecutive odd integers required, the consecutive positive and 11 plus 2. That is the answer, though not required, but you can yourself check up here. 11 square is 121, 13 square is 169, summing up to 290. It's a verification of the work done, though not required. Yet I have shown to you the actual meaning of the question, rather the spirit of the question. 2 consecutive positive odd integers 11 and 13, sum of their squares being 290. Similar question here, if the sum of the squares of 2 consecutive positive even integers, even then you take x and x plus 2, because even integers also differ by 2, odd integers also differ by 2. They form AP with a common difference of 2. So you can take x and x plus 2 even in this case and continue with the same work, but while accepting the values, be careful and go by the data of the question. They require consecutive positive even integers. While accepting these value or rejecting that value as not admissible, be careful about it. Find the number that exceeds its square root by 12. This word often used in mathematics. It confuses the students whether this is more or that is more. For a convenient reading, always replace this is more than or is greater than. Now let us read. Find the number that is greater than its square root by 12. That's what I am saying. Question says that exceeds square root by 12. You may get confused. Exceeds means which is more, which is less. I am telling you very simple. Remove this word and write is greater than or is more than. So find the number that is more than its square root. Greater than the square root by 12. It is the number required be x. Given. What is given? Number is more than its square root by 12. This is the number, this is the square root. Their difference is 12. That is what the question says. Find the number that is more than the square root. So this number is more by 12. Solving. X minus root x is here. Factorization, simple factorization. This value is not acceptable because a number that is not minus 3. Square root of a number is plus 3 or minus 3. You can't take minus 3. So I am taking only x is equal to 4. Please see here. 16 is not admissible. X is equal to 16. Find the number required is 16. Before proceeding to the other question, let us have a small verification also. Your number required is 16. Its square root is 4. So this exceeds by 12. That's what the question says. It's a sort of verification, though not required, yet we have to understand the spirit of the question. The player A took 1 wicket less than twice the number of wickets taken by the player B. If the product of the wickets taken by the two players is 15, find how many wickets did A take. Look here. Let x be the number of wickets taken by B. Read the question. A took 1 wicket less than twice the wickets taken by B. B took X wickets. So A took 1 wicket less than twice this. Understand the language of the question once again. A took 1 wicket less than twice the wickets taken by B. If the wickets taken by B is X, its twice is 2X, 1 less is 2X minus 1. If the product of the wickets taken by the two players is 15, B took X wickets, A took 2X minus 1 wickets. Proceed. Once again, I want to do factorization only. It is convenient. Watch carefully. Two values of x. One is 3, other is minus 5 by 2. Here x denotes number of wickets. That can't be minus 5 by 2, so 3 is the acceptable value. You have to write, since x is equal to minus 5 by 2 is not admissible value, therefore x is equal to 3 is the number of wickets taken by B. My question asks, how many wickets did A take? So A took 1 less than twice this number. Twice this less 1. This is your answer. As a verification, you can see A took 5 wickets, B took 3 wickets, product is 15. That's a sort of verification.